Hi and welcome back to another video. I am traveling again. I'm back in Taiwan. It's been a very long time, over 3 years, that I had the chance to come here, mainly due to the pandemic and regulations. It was always quite difficult to come here. Now regulations are pretty much gone, or restrictions. So yeah, I'm back here and I want to visit ASUS, mainly because of Sapphire Rapids platform. They should have plenty of CPUs, 56 cores, and also meeting all the people again, like Elmor, Peter, didn't see them for a very long time. So I'm very happy to be back, and should be a nice week. Going to be here 6 days, and I will take you with me. On the way to the metro now. Still have to pick up some money first, but it's very convenient here. You can pretty much withdraw this anywhere, and then gonna take the metro towards ASUS, and on the way I will grab some bubble tea. And some might say bubble tea, WTF, and I kind of agree. I mean, in Germany I would never have that, but here they have this very specific bubble tea store I really like, and I haven't had that for so many years, so I'm definitely getting one on the way. First getting an easy card, which is like a card you can top up. Nice, it's a new design. And you can use it for metro, you can use it for taxis. It's very convenient to pay. I'm not sure if you can see it, but the metro on here is Pokemon style. Not even bad. Honestly, these things, they kill me every single time. Coco, that is the place I want to go to. Perfect. Now I just have to grab a taxi to get to ASUS, because it's not that convenient to get there by MRT. And here we go, back at ASUS HQ. I've been at this building before, but that was like 6 or 7 years ago. I was overclocking with Andre Young here, and after that they moved to a different building, the ASUS R&D guys from the mainboard department. But they are now back at this building. It's not only the motherboard department, but also Pegatron, which is basically the head above ASUS. And yeah, let's just enter in there. It's also a pretty cool detail if you enter in the entrance hall right here. So they have a Mona Lisa, and it's just fully made out of like tiny old mainboard components. Okay, so ASUS wins 11 awards a day. Should have brought my RGB award. Probably that's the one you don't want to get. Now arrived at our testing room for this week. So we have a lot of testing spots. In this corner we will have Massman, who is the previous manager of HWBot and also the owner of the Scatterbencher YouTube channel. Here we would have Elmor. Here we would have Team OGS, that's an overclocking team from Greece. But as you can see, nobody's here yet. But I'm also here quite early. And that will be my spot for testing Sapphire Rapids. We have plenty of CPUs, plenty of boards, plenty of everything what you could wish for, and of course also liquid nitrogen for later. What we're also testing and using this week is the full version of WireView, which I did not show yet. I mean, you probably are familiar with these tiny adapters, which I showed already in a lot of videos, which are basically GPU 180-degree adapters, but also capable of measuring the power consumption. Hey! That's Sunho. It's in-house overclocker at ASUS, legend, owner of plenty of overclocking records, and also supporting us this week. Very happy to see you.
Nice to meet you.
So for WireView we have these power adapters, which are capable of measuring the EPS power. That's what, for example, also on the GPU WireView, this white connector is for. That's something I did not show yet, because this allows to connect all kind of WireView adapters with this central control unit, which then allows to like measure all the voltages and at the same time, of course, the current. And this way get the power consumption of the entire system. So not only the GPU, but also like 5 volt, 3.3 volt, and then like hook up as many like EPS power connectors as you need. Because on Sapphire Rapids, I mean, you have 4, because we are using 2 PSUs, and otherwise measuring the power consumption during the benchmark run is not that easy, it's not that convenient. And with this, we can just have it all combined. The entire first day I basically just spent testing general things with Sapphire Rapids. And you might remember one of the videos a few weeks ago with my first steps of the 56-core Xeon 3495X. Everything felt kind of buggy, like Windows was extremely slow, and even if you just wanted to open up Explorer, it just didn't feel right. And after additional more tests, we figured out that disabling HPAD solves this problem. I'm not sure if it's supposed to be this way, but at this state with HPAD enabled, everything feels really odd, and I'm not sure if Intel is still working on that. Anyway, so continued with the 3495X overclocking. And when I tried this at home, I only had a Noctua air cooler. And honestly, if you have an air cooler, this is okay for stock, but overclocking, there's just no way it can handle the additional heat output. Because just the slightest overclocking will cause the CPU to consume at least 600 to 700 watt. With this NMX 360 AIO, it was definitely better, and pretty much similar to what we tested already in the US in the Intel OC lab. The CPU was able to handle 4.0 GHz at about 1.0 volt core voltage. These Sapphire Rapids CPUs in generally run at a very low V-core, and that's just necessary because otherwise you will not be able to handle the power output. In Cinebench R23 with this configuration of 4.0 GHz, I could achieve about 96 to 97,000 points. The memory was running at about 6,000 megatransfers C32. The memory kit itself is able to handle 6,800 megatransfers, but we noticed that in some benchmarks it was just better to run a lower clock speed but with tighter timings. This video is supported by G.Skill and their brand new Zeta R5 DDR5 RDIMM kits, which are the perfect match for Sapphire Rapids. Zeta R5 are the first DDR5 RDIMMs that support XMP 3.0 with 6400 C32 and are perfect for overclocking. From our experience, during this weak overclocking Sapphire Rapids, these kits can often even be pushed to 6800 C32 or C34, and G.Skill already showed insane read speeds at about 315 GB per second with these settings. Especially considering that we are talking about registered memory, this is insane. If you are going to buy Sapphire Rapids, you should definitely consider these sticks and check them out in more detail. Kits with 256 GB size and 6000 C32 will also be available. Find out more in the link below. Testing R23, I noticed that the first 28 cores got quite a bit warmer than the rest. But you have to keep in mind, the Sapphire Rapids CPUs, at least the bigger ones, are made out of 4 individual tiles, 4 individual chips. It's possible that some of them are better and some of them are worse. At least for ambient overclocking, the nice thing about Sapphire Rapids is that it contains FIVR, so fully integrated voltage regulators. And you might remember this from Haswell or Skylake X CPUs. In this case, a higher voltage, for example 1.8 volt, is fed from the mainboard to the CPU. And only internally inside the CPU, this is then transferred into the core voltage, which could be 1 volt. And the cool thing about this is that FIVR controls every single core. This means that we can feed an individual voltage to every single core inside this 56 core CPUs. And this way we can make use of temperature differences, which means that if one die is colder, we can simply feed our higher voltage to this one and thus clock it higher. At this point though, the NMX AIO was fully saturated, so I had to change to an EKWB custom water cooling kit. It's using a rack mount CPU cooler, which is using the fittings from the front, but that doesn't really matter, and for the test was totally fine, and I was seeing about 10 to 15 degrees Celsius lower temperatures with this 480mm radiator. With the EK block and more headroom in temperature, I thought it would be easy to run 4.4 or 4.5 GHz. But that was not the case. Even though I kept increasing vCore up to 1.15 volt, it always instantly crashed. So I had to spend a bit more time testing, and then I figured out that running the default input voltage of 1.8 volt is just not enough. So I had to increase this to 2.5 volt. So that's the voltage which is fed, as I said before, from the mainboard to your CPU, and then internally changed to the vCore. And changing this from 1.8 to 2.5 will decrease the current running from your voltage regulators to the CPU. So it's a lighter load on the VRM, but at the same time it's increasing the load on the FIVR inside the CPUs. So it's also increasing the core temperature a little bit. But if you drastically increase the input voltage, you will at least decrease the current flowing from the VRM to your CPU, in my case by about 30%. With this setting, it was possible to run 4.7 GHz on all of the 56 core and pushing this through R23. This equaled in 114,000 points in R23 with water cooling. To give you an idea of the performance, this is quite equal to a Threadripper 5995X, but with dry ice or liquid nitrogen at about 5.1 GHz. And at this point, I just didn't see that it would be possible to increase it further on the Xeon because I was already running 1.13 volts. And for 4.8 you would need even more vCore, but I was already at a thermal limit. One way to bypass this thermal limit obviously is running liquid nitrogen. And running this significantly lower temperature helps us to reduce the power consumption of the CPU, which then gives us a higher headroom in increasing vCore and at the same time the clock. In the end, you should not forget that these 56 core are pretty much Alder Lake cores. So in the end, those are 7 12900Ks you have to cool at the same time. To be able to mount our liquid nitrogen container, we first have to remove the stock mounting mechanism. This is quite a bit different from any kind of desktop socket like LGA 1700 or AMD's AM5. We have to use normal threaded rods to mount our liquid nitrogen container, and for this we have to use a custom mounting plate, because on LGA 4677 it's not using an ILM or like an SEM as you have on AMD, but it's using the mounting pressure applied by the cooler. And especially with liquid nitrogen, this can be quite difficult because you have to keep in mind that we have a high temperature delta from mounting the container at room temperature, let's say 20 degrees Celsius, and then we go to like -90. So we have a huge temperature difference which causes shrinking within the different materials, and this is causing a change in the mounting pressure. And in case your mounting pressure is too low, you can lose memory sticks, which happened to me several times. So you just restart and then suddenly only 7 out of 8 memory sticks are detected, which means that you basically have to heat up and mount everything again, worst case. But that's something that pretty much only applies for these extreme cooling methods. At least on ambient, I never had any issues. After a few attempts, I was able to run the CPU at -80 degrees Celsius, measured from the LN2 container at 5.2 GHz, which results in 125,000 points in R23. Interestingly though, the Xeon W9 3495X only allows to run a max multiplier of 52. Which is not really that much, especially if you would compare this with a 12900K, which is basically running this stock. So higher multipliers are just not available in this CPU, even though it's advertised as like unlocked. That is quite odd. But there's one way how we can improve this further by increasing the base clock, so the B clock. But even with this, I reached the limit at 5.3 GHz with about 128 and 600 points, at least at the point shooting this video. This was a new world record in Cinebench R23. Previously, it was held by the ASUS in-house overclocker Sunho with about 300 points less. But I also want to point out that Elmor spent quite a bit more time with a different CPU on this and was able to improve this a lot further. Significantly increasing the performance further doesn't seem to be possible, at least at this point, especially keeping in mind that the CPU multiplier is capped at 52 ratio. Because if we increase B clock, we at the same time also increase cache and memory clock, which will make it more complicated. To me personally though, still very impressive results, and I spent about 3 days testing with Sapphire Rapids. And of course only a small portion is in this video, but still, I learned a lot these days, and that's why I want to thank ASUS again for the opportunity to be part of this. Stavros and Phil, who form the Greek overclocking team OGS, in the same time were testing a Galax RTX 4090 Hall of Fame. And especially keeping in mind that we used Sapphire Rapids as a base platform, this is a true challenge, because both CPU and GPU are not easy to handle at very low temperatures. Still, in times by extreme, they could achieve over 23,000 points, which is a new record. The RTX 4090 was running at a tough 3600 MHz. At the same time, shout out to Phil, who managed to drop a 3495X CPU. Luckily, the CPU did not hit the corner or the PCB itself, but just the IHS on the side. So the 6000 euro CPU was still working, and I'm happy to say that I'm not the only person who likes to drop big and very expensive CPUs. Elmor from Elmor Labs was also part of the gang, and at this day he spent his time benching together with Shamino the 3DMark CPU profile test. And the previous record was done with a Threadripper 5995WX with about 39,600 points. And already with water cooling, the 3495X 56-core Xeon could achieve 39,300 points. So only a little bit of improvement with liquid nitrogen was necessary to break the record. Interestingly though, this new CPU was not yet known by UL, so by 3DMark, and still had to be added to the benchmark list. That's why it was not that easy to submit it, but after a bit of tweaking, Elmor achieved 41,000 points, which then was a new world record. The CPU profile benchmark is also pretty quick and also only a light load for the CPU. This means you can typically run about 100 MHz more with these CPUs than in Cinebench. You will still remember the 1000 watt I was running earlier with my AIO. And with this CPU here, with about 5.3 GHz and increased V-core under liquid nitrogen, this CPU was pulling 1800 watt. 2 power supplies are required to power the platform in this state. And now if we keep in mind, you would even run a 3DMark bench, maybe with a 4090, you at least need 3 PSUs, or worst case even 4. One quick update shot at the evening, because obviously we're not overclocking the entire day. Well, basically the entire day, but not like 24/7. So it's like 11 p.m. now. We just had dinner, and that's also one of the fun parts. That's why I love coming here, because there's a lot of friends and it's also a lot of different vendors. So we just went to dinner, and it was not only ASUS, it was also somebody from ASRock, somebody from Corsair. Everybody knows each other, everybody respects each other, and has a lot of stories to tell, which is very nice. And now we decided to take a trip to the Elmor Labs office. So,
what do people want?
everything. Yeah. I'm not sure what it is, but
Strawberry. Oh.
otherwise, definitely can recommend these. What is that?
Strawberry flavored alcohol. It was pretty good, but also not good. You don't have the L2 drink?
Not sure.
No L2 drink.
No L2 drink? Okay.
Thank you.
Where do you come from? Stairs?
Wow.
Maybe this way you can stay young.
Stay young. No, I need to go to the Health Master company.
We were just going through his storage because he wanted to show me some interesting prototypes, and there is a quite unique one. So here we have it. It's a very unique thing and a very useful unique thing, or should I call it useless? In theory, it would be an adapter for PCIe X16, which you can plug into your motherboard, and then you can plug power on here, and this way measure the current that is flowing through the PCIe slot. But something went wrong here. And maybe you can spot what exactly went wrong, and maybe you have an idea how this happened. So yeah, if you have any clue, let me know in the comments. And we have one more failed project. That's also something I at least wanted to do with Elmor. Well, it's not his fault that it's failed, but my idea was that I wanted to use this, as you can see, as CPU cleaning tool. So you can see my logo, you can see this tiny hole and a very sharp edge on here. Our original plan with this was to use this to scratch off the indium and also the leftover glue on AMD Ryzen 7000 CPUs and to bundle it with the delitter. Turned out when I tried it, it was fine to scratch off the indium, but it was too strong, like the material too strong, too sharp, and it actually damages the PCB when you scratch off the glue. I tried it once, I instantly killed the CPU, and that's sometimes things that go wrong, things that you try that don't work out, and I mean that also adds up to the development cost, let's say, of a Ryzen 7000 delitter, because I try multiple things that damage CPUs, that kill CPUs, but it's because I want to do it so you don't have to damage it. But yeah, it's one more failed project. On the third day, I was done with testing Sapphire Rapids, and I wanted to move on to an entirely different topic, Ryzen X 3D. Specifically, I was interested in if there is any other way we can tune the X3D CPUs, maybe overclock it, and what kind of risk we will see with increased voltage. Already with the 5800X 3D, AMD stated that it would be a great risk to overclock these CPUs or also increase voltage. So I grabbed a 7950X 3D and also a Crosshair X670E. Interestingly though, if you open this BIOS, you can see that you can adjust the core voltage. And at least comparing this to the 5800X 3D, this seemed new. The stock voltage of these CPUs are very low and under the load typically around 1 volt. So I first decided to set a voltage of 1.35 volt, which is definitely a solid increase, but at least subjectively seemed to be kind of okay. I also want to point out that depending on how you set the voltage, the CPU has no control over what you are doing, because you can do a manual override and thus just feed any kind of voltage to the CPU you want. The CPU basically cannot do anything against it. It was already quite clear though that there is no way that an AIO can dissipate this heat. And it's actually not the heat that's a problem, but it's the hotspot inside the CPU and the power density. Because the amount of heat itself is not a problem. You're not saturating the AIO, but the heat cannot be dissipated quick enough through the chip to the heat spreader and the AIO. That's why I just decided, okay, I'm going to grab a liquid nitrogen container and put it at the CPU and maybe keep it at around 10 degrees Celsius. And first test under load with Cinebench R23 and 1.35 core voltage seemed to be okay, at least 85 to 90 degrees Celsius, kind of similar to stock if you use a different cooler, and it did not throttle. And so I decided to increase the voltage further, 1.55 volt. At least compared to the stock voltage, that is a significant jump. But compared to a current Intel CPU or also to a current non-X30D CPUs, this is fine as long as your CPU is cold enough. So I thought, okay, I'm just gonna run the CPU container colder, maybe like 0 degrees Celsius or like -10, and then this might be fine. But yeah, I did not expect this. At the moment, when I applied, I could only see 0, on the mainboard, which honestly surprised me. And first I was not quite sure if this is correct or if I have any other issue. So I tried all the typical debugging steps, like safe boot, BIOS reset, and I even reseated the CPU, which was pretty hot, and then also tested with a different CPU. But still, the CPU is dead. Honestly and seriously, I did not expect this to happen, especially so quickly and especially just right out of the BIOS without any significant load. I would have expected this maybe with bad cooling and Cinebench, but without load, just out of the BIOS, that was insane. I also want to point out it would not be scientific to draw a conclusion from this. I can only tell you that at least this single sample died at this voltage. Why, I cannot really explain. Obviously, I did not want to ask ASUS for another maybe 9 7950X 3D CPUs, so we have 10 and some kind of scientific data. Yeah, I think that would not be right. But it seems to be quite dangerous. In the end though, I think it's quite ironic that you cannot modify the CPUs when it comes to the clock, but the voltage is not locked. Honestly, I have no explanation for this, and I think it might be an oversight from AMD's side that they maybe forgot to tell the mainboard vendors to lock the manual voltage. Because I have no other explanation for this. It does not make sense that, let's say, the 5800X 3D was fully locked, and here they lock the clock but not the voltage. If you just look at this, like changing the clock will not damage your chip. And we know that you have the boost clock, for example 5.2 GHz. You will have this clock across all of your cores at a certain time. So you will have different cores at different times boosting to those frequencies. And if you have solid cooling, it should be possible to run this kind of clock across all of the cores. It only requires the cooling, because the higher clock will also increase power consumption slightly and thus temperature. At this point, all I can say is that it doesn't make sense that the clock is locked and the voltage is not locked. It just seems like a simple oversight, and maybe AMD has to work on this. To double check further, I decided to measure the resistance from V-core to ground to see if the CPU is actually dead. And measured, it was below 1 ohm. And as a reference, a functioning 7950X 3D in socket measures about 1.7 to 2 ohm, at least with this DDM. I then proceeded to measure both CPUs individual outside of the socket. So I first had to locate some V-core and ground pads on the back, and I also marked them with this pen so I can easier find them again. And with the functioning 7950X 3D, I could measure about 1.1 ohm from V-core to ground. And with the dead CPU, basically 0.0 ohm. So yeah, indeed actually dead. I then quickly checked with AMD and ASUS, and by the information I could gather, I am pretty sure that it was not intended that it's allowed to run such a high V-core. After my testing, ASUS will probably limit the max manual voltage to 1.35 volt to just prevent such damages on X3D CPUs in the future. And personally, I also think that this is the right decision, even though this is kind of against my overclocking heart. But still, in the end, I mean, these CPUs are locked, so you cannot really make anything with the increased voltage, and it's just a significant risk. So I think in this case, it makes sense to have this kind of safety. And I also want to highlight, please don't take this out of context, because at least for now, it's just one X30D CPU that died at a higher voltage, and this cannot be translated to non-X30D CPUs, because I used a lot of other Intel and also AMD CPUs with much higher voltage, and it was never an issue. Also keep in mind, we just don't know what happened inside these X30D CPUs that caused such a quick death. But now, finally time for dinner. So tonight we're going to go for traditional Taiwanese food.
Here. You want stuff here?
The interesting part is that this is the old ASUS office, and like right here there used to be a very nice restaurant, like one of these like street places, and it kind of closed down, but there is a new one that looks pretty similar, and I think we're just going to try that. But like the local food is so nice, the stuff they have. I'm a big fan of fried rice and cabbage. I hope they have that.
So it's a curry beef fried rice. Curry beef fried rice.
Thank God he knows a bit of Chinese, otherwise completely lost.
Yeah, let's get one of those. Alright, well, cheers.
Honestly, if you ever make it to Taiwan, like these are the places where you have to go to. Like that food is absolutely recommended.
Oh, it's a tomato. 那这个没有吗？
有啊，那酱油的。
对。
哦，酱油的，看一下。
谢谢。
谢谢。
Okay,
拜拜，拜拜。
So that was amazing. The funny part was that we thought that the place shut down. It was a place we've been to I don't know how many times when ASUS was still located at another place. And I was already kind of sad because the food was so nice and the lady there was also so friendly. And then we went to this new place at the same location, which was like a little bit smaller. Turns out it's the same people running it, so they kind of renovated it, made it a new small place, and the lady even recognized us, even though, I mean, we were there last time like 3 or 4 years ago, and she still knew who we were, and that was really nice. So yeah, tomorrow, last day for me. I still want to play around with Sapphire Rapids a bit, do maybe some memory stuff like memory bandwidth with AIDA64, and also play around with an unreleased AMD platform I obviously cannot talk about, but we might talk about that like in half a year or something. On the last day I wanted to look at memory performance with Sapphire Rapids and AIDA64, which was not optimized yet for this platform, but it still worked. And we were testing this with the 24-core, so the 2495X CPU, which was running at 5.0 GHz, cooled by an EKWB water cooling. This is the smaller CPU, so of the 24 Xeon series, and only made out of a single die, and this allows to run a higher clock. But at the same time it also only has quad channel. That's why the expected read and write rates are lower. We see about 150 GB per second read and about 111 GB per second write. Compared to any other current desktop platform, it's still pretty quick and much quicker than, let's say, a 3900K or 7950X, but you can see that the latency with 80 nanoseconds is rather high, which is caused by ECC RDIMM, which also obviously has positive attributes for different systems. Unfortunately though, I did not have the time to repeat this entire testing again with the bigger CPU and octa channel. Last evening, and we are going to go shrimp fishing, which is pretty much the most Taiwanese thing you can do, I think. So that should be quite entertaining. So just to explain how this works and what this actually is, so you have those pools right here that are filled with shrimp. Obviously you cannot see them because the water is not really clear, but you get like a fishing rod and then you sit down here and put it in, and you get like some bait and you try to get some shrimp, which you can later on then eat. But I mean, for us it's not really about the fishing, but it's just like enjoying the time. We've actually been here before, like 3 or 4 years. We're actually sitting right there with some guys from AMD, Bill, Amit, saying hello, and yeah, should be quite nice. So what you just saw is the guy with the bucket, he threw in the shrimps. So I have my fishing rod, I have my bait, and now we're ready to go. So well, that's our dinner.
Right. So how do I open it?
I mean, in the end you have to put it on a stick and then you basically barbecue it. It will look like that.
Maybe there is soy sauce and wasabi.
Now it's Saturday morning, 4 AM. Just came back from the shrimp fishing and everything. Of course, I went to shower first because, yeah, otherwise it would be quite an interesting, smelly experience for the rest of the people in the plane. But yeah, that's basically a week of overclocking. Obviously it's just like a fraction I could show to you, otherwise the video would be even longer than what it became now. But I hope that I could give you an impression how things turn out when I come here for like 5 days. And it's just something special because it's not just like overclocking the CPUs, it's the entire thing with the industry, meeting the people, just enjoying everything here. It's an amazing experience, and I hope I could share a bit of this. And now I will fly back with EVA Air, aka the Hello Kitty airline. Thanks for tuning in. See you next time. Bye bye.